Start recording. Sorry I was a minute or two late. Working on, had some room issues come up for the fall semester. I'm trying to resolve a couple room issues. That's what we'll just leave it at that. Okay. Let's see what I'm doing. And okay, so Ryan, I know you had a question relative to 120E problem, or excuse me, a 120 problem, and we can address that here before we leave today. If you still have questions on a 120 problem, and so for today, want to look at the 120E stuff first. Is there any questions relative to homework assigned and or quiz problems from 120E? Once, going twice. All right, well, in that case, want to look at problems that we'll have for homework here for the next week. This is out of 3.1. And looking at some more fractional work, we had looked at adding and subtracting fractions, so on and so forth. So I'm just going to go through and do some of these problems and talk about the arithmetic involved. First problem, 1 1/3 divided by 4/7. Now, recall that divide by means flip and then multiply. And to get this multiplied, if we have a mixed fraction, as this one does, we're going to need to rewrite it as an improper fraction. So, and the easiest way to put this in improper form is just go 3 times 1 plus 1. So it's 4/3 divided by 4/7. So, which means this is 4/3 times, and again, flip, 7/4. Now, we got common factors of 4 top and bottom. So we're left with 1 in each case. And so my final answer here is 1 times 7 is 7, and 3 times 1 is 3. And so I get 7/3. And I'm going to check here. Yep. And you didn't even have to read it. It just said type your answer. The blue part in the field says type as a whole number or simplified fraction. And it took 7/3. You didn't have to rewrite it as a mixed fraction. Okay. All right. And now, this deals with some verbiage, number 2, associated with place values, which if you're at the 120 session today, at the end, we were talking about scientific notation, and we talked about our positional place value system a bit in terms of it uses base 10 and so on and so forth. And so this is really follow up with that. It gives you a number of 49.358. And it asks for 3 different things. It says ones place. Well, your ones place is 9. And then it wants tenths. And the phrasing there is important because the other thing it asks for is tens place. And then also tenths place. Now, that THS, it's 3. So if you have a number and it's got a decimal part, that first digit occupying here is tenths. This is hundredths, thousandths, and so they all have the TH there. Now, where's that coming from? This place value right here. So this place value in terms of its base is 10 to the first, tens. So tens is 4 in this particular. The digit 4 is occupying tens place, 10 to the first. 1, anything to the 0 power is 1. And then so it would make sense you would have 10 to the negative first, 10 to the negative second, 10 to the negative third. And remember that a negative exponent means reciprocal of the base and then that power, the reciprocal of 10 to the first, which is 1/10. And there's that TH. And that's where this TH is coming from. Anyway, so we're good with that. It's just place values. Kind of review over place values and the verbiage associated with it. Okay, so 3 is more of the same. 4 is more of the same. 5 is more of the same, just place value stuff and terminology. Well, actually, no, 5 is now moving into taking a number in decimal form and writing it as a fraction, which we actually did a little bit in class today. So if you had 0.625 and you were going to write this as a fraction, first is count up your place values. This is in thousandths, TH, place. That is 625 over 1,000. And that is because you would have tenths, hundredths, thousandths place. So it's a fraction, 625 over 1,000. But then you just need to reduce this as much as possible. You could divide top and bottom by 5. Let's see, divide top and bottom by 25 for sure. Ultimately, that is going to reduce to 5/8 when all said and done. All right. 7 is just like 8. Now, number 8, this was actually kind of number 6, I believe. Number 8, the problem says on number 8, rewrite the following words as a decimal number, and you have 41 hundredths. 41, that's a U, hundredths, the THS. Okay. So what I do is I take this part, I think that is to 2 decimal places past, that is to the right of the decimal place. And so this would be, or another way to think of it is if you just phrase it as 41 hundredths, it's just like a fraction, right? 41 over 100, which in decimal form is 0.41. So another way to, you can either think of it, put it as a fraction, 41 over 100, which then in decimal form is 0.41, or you just 41 hundredths, okay, that's 2 decimal places, 0.41. passed. Okay, more of the same. More of the same. Number 11 is just a quick rounding problem. Still 3.1. You're given 43.5643. It says round to tenths place, or round to the nearest tenth. And so, go to the digit that occupies that place value. Here's your tenth, and then look at the next digit. If it's 5 or more, this rounds up. If it's 4 or less, it stays the same. So this would round to tenths place, 43.6. I'm going to go ahead and do the next one. You're given 0.296, and it asked you to round to the nearest hundredth, which is here. Now, since that's a 9 and the next digit's a 6, you haven't got anywhere else to go past 9. So what happens is it goes to 0 and the tenths place goes up by 1. So 0.30. And technically, you could actually just write 0.3 since 0 is not significant. That'd be rounding to hundredths place. And yeah, that should be okay. Should be fine there. Okay. So on this problem, use front end rounding to round each number to get an estimated answer. So looking at number 16, talk about front end rounding. Now, the problem is 6.7 less 2.866. Okay, when you front end round, and so it's kind of right, that is different than the normal rounding like we did here where we rounded the tenths. And so hundreds place was more than 5, so I rounded the tens place up 1 to 6, and then here to hundreds place, the same thing. Front end rounding is different than that kind of rounding. Front end rounding, you're going to have one non-zero digit, and it's going to be to the closest one based on what this digit is. So if I have 6.7, then I would round this front end round to 7.0. If this had been 6.2, I would have front end rounded to 6.0. All right. So this is the front end round. Estimate. This one right here, I've got 2.866, so I'm going to front end round it to 3. Again, if it had been 2.466, I would have front rounded it to 2.0. And then I simply subtract the 2 and I get 4. And so that is my estimate. And that answers on 16, part A. Part B, it just wants the exact answer. And so that is going to be 6.7 minus 2.866. So you just actually get your calculator out and do the actual calculation, which is 3.0 834. So, any questions on front end rounding in terms of estimation? Okay. And more rounding. Then it's just take some fractions. The last problems are take some fractions and write them as a decimal, and so on and so forth. So that is 3.1. And tell you what, I think I'm not going to go into 3.2. So what I'm going to do is give this same due date as I did in morning class. All right, so the due date I put on here was the 6th, which is next Tuesday. So everybody else, I believe, heard this morning. Ryan, you were not here. The campus is closed on the 5th. College is closed for the 4th of July holiday. Ergo, we will not have class on Monday. And when I send out the Zoom links, the video links for the lectures, I'll remind everybody in there, no class on Monday. So our next class will be the 7th. So I put a due date of the 6th for this homework that I'm assigning 3.1. And I'm not going to go any further. So what I would ask now, we still have time left. Any questions from 120? I know, Ryan, you may have had one. I don't know whether you got that worked out last night or not. So
No, I did not. Can you hear me okay?
I can.
Okay, sorry, I'm actually at the college right now, and I had to leave my system behind. So I'm at the college right now, but I'm for some reason I just couldn't. And I tried using the view as an example and to help me solve this on the math thing, but I'm just having trouble understanding how you get to each step. Like when it was asking for kilowatts per day, I just don't understand how you get those parts.
Gotcha. All right, so let me get into, this is back to Math 120. And this would have been in 2B, correct?
I believe so. I actually have it pulled up here. Yes, 2B. It was question 11.
Okay. Okay, so I'm going to go ahead and turn the page. And you're looking at 2B, number 11. Now, if I remember, I on the video, there would be an example of 14 and 15, but I never did work 11 in class. So this would be new to everybody in terms of at least working it in class. All right, so I'm going to work through the problem and kind of try to hopefully help you understand the setup. So your numbers are going to be different when you work this. But it's all about, when we're working these problems, getting things set up so our units that we're using will cancel out to leave us with the desired units. And that is where we get things top. We're multiplying, by the units are really a factor of 1, and we arrange them such that we get things top and bottom to cancel out. Now, So for this problem and the numbers I'm looking at, we've got 16 cents. So I'm going to write that as 0.16. And per, so cents per kilowatt hour. 16 cents per kilowatt hour. So in terms of units, I have dollars over per kilowatt dash hour. That is a unit, all right? So that's the rate at which our utility company is going to charge us for electricity. Now, it says we got a couple questions here based on that rate. A, what is daily cost of keeping lit a 120 watt light bulb for 15 hours each day. All right. So we pop in a 120 watt light bulb, such as the light. I think you can see that one back there, but it's on for 15 hours. So the question is, how much is so? It's going to cost us. All right. So now, thinking about at the end of the day, I know the unit I'm going to want is dollar. That's the final unit I want. I've got a rate in dollars per kilowatt hour. So what I need to figure out is how many kilowatt hours are used. All right, so that's going to be my first goal. Figure out how many kilowatt hours are used in that period. And once I know that, that tells me how much power, then I can multiply that by my rate, which was 0.16. All right. Mm-hmm. Now, so the first thing is, on power on the light bulb itself, it's rated at what, 120 watts. All right. So what I'm going to need to do is, and this is kind of where metric system kicks in. From watt to kilowatt is 1,000. Right. So I'm going to write down write down the calculation. So we know we got 120 watts. All I want to do now is get this in terms of kilowatts. So 1 kilowatt is 1,000 watts. So this is just a factor of 1. But notice right there, that gets rid of my what? Watts. They're going to cancel out and leave me with kilowatt. Right? And this is going to be over a period of what? 15 hours. So that's why it's kilowatt dash hour, because they didn't cancel out kilowatt dash hour. Okay. So to get your kilowatt hours, which is what the power is measured in, again, I know I'm using 120 watt light bulb. And so this is just converting watts to kilowatts. That is 120 divided by 1,000. And then over that time period, hours here. And so I would just punch my buttons on that. And so Where's my calculator? Let's see what that's going to give me. So I can just do 120 times 15 divided by 1,000. All right, so that's going to come out to 1.8 kilowatt hours. And that's a dash. I want to make that a little clearer.
Now, let me ask this real quick.
Sure.
So okay. So you do the 120 divided by 1,000, which is 0.112 kilowatts.
Mm-hmm.
Then you're timesing the. Are you timesing the 0.12?
Yes, that is times by 15, because you're going to leave this. You're going to leave the light bulb on for 15 hours.
Okay.
And
okay.
So if you would just go, just so you can kind of maybe get it again, we're trying to get your head wrapped around it. If I had just went 120 times 15, which I'm going to do that real quick, get that number, 120 times 15, that gives me 1,800. And so that would be, the unit would be watt hour. And it's just, but electric companies use kilowatt hours.
Mm-hmm.
And again, it's a metric thing. So instead of grams or liters, we're using it's watts. But these prefixes work the same. So kilo is 1,000. And notice if I move my decimal place 3 places, 1, 2, 3, that puts me at what? 1.8. Does that, I don't know, does that help?
That does, yeah. So I guess where I was getting confused, I was trying to cancel out the hour, the hours part of it, and
Nope.
yeah.
And because the units are in kilowatt hours.
Okay. Now,
okay.
There was another question involving, it had to do with water and sea level. I believe it was cubic kilometers, I believe, or
Mm-hmm.
I'm not sure, but now is that the same? And that would be the same situation here, where you're trying to.
Yep. Same. So, and so those prefixes, and I'm going to give you a, which you would have to catch it in the video, but in the e-text, give me a second to flip to this page because it's back in, it's in 2B. I believe it's in 2B. It may be in 2A. It's in 2A. It's in 2B. So just for reference, page 91 in the textbook. So for you, it's the e-text. At the bottom of the page, table 2.3 gives you the breakdown, so that if you are at watt or gram or liter, and I were to look at a deciliter or a decawatt, then that's just tenths. You've just moved one decimal place over. Hecto is 100, kilo 1,000, mega is 1,000,000, giga is 1,000,000,000, tera is 1,000,000,000. And but there's a table there that you can reference with those terms. Okay.
Thank you so much.
Oh, you're welcome. Now, to get your daily cost, because what we were trying to get here is what was the daily cost in dollars here. Then that's where I multiply. Now watch what happens. So how do I end up with dollars? I can now take my 1.8 kilowatt hour and multiply that by my rate, which was $0.16 per kilowatt hour.
Okay. All right. I get this now.
And now you can see those units cancel and leaving me just with dollars. And so you just go 1.8 times 0.16, which comes out to roughly about 29 cents or 0.288. So your daily cost, which, that seems like a reasonable cost, unless you're a dad. And that dads are notorious for telling kids and to what, turn off the light. But legitimately, it's going to cost you about 29 cents for the day to leave that one light bulb on.
My thermostat alarm goes off quite often when someone messes with the thermostat.
It all costs money. So now there was a second part to this question. How much will you save in a year if you replace the bulb with an LED bulb that provides the same amount of light but only uses 12 watts of power? All right. So fortunately, I have run out of room here, so I'm going to have to turn the page. So we're still looking at number 11, but now part B. All right. So how much saved in a year if you use an LED bulb that uses 12 watts of power? And I'm not sure what that is. It's supposed to be a question mark. There we go. All right. So, so in this particular deal, the first, if I want to know how much I'm going to save, I got to figure out how much I'm going to spend for the whole year using, because I'm trying to figure out and comparing savings, how much for the 120 watt bulb. So how much for the year? So we already know it's at 0.288 dollars per day. That was my daily cost. So I got to put that in terms of years. That is dollars per year. So conversion, 365 days per 1 year. So my days will cancel. Now I'm at dollars per what year? And I would have to go 0.288 times the 365. So when I make that calculation, that comes out to 105.12 dollars per year. Okay. So if I leave that bulb on every single day for 15 hours a day, I'm going to spend $105.12. Now, to figure out the savings, I'm going to basically do all the same calculations, except I won't have 120 watts. I will have just 12 watts. But I got to convert it to kilowatt hours. So that's where I have the 1 kilowatt divided by 1,000 watts times my 15 hours per day times my rate, which was 0.16 dollars per kilowatt hour. Oh, excuse me. kilowatt. There we go. And then times 365 because it's for the whole year. So I just put them all in one. That's a year. All in one big long string, but it's all the same exact calculations we did for part A to arrive at that it's going to cost me. So if I just drop from a 120 watt bulb down to a 12 watt bulb, it's going to cost me $10.51. Now you would note that's like I just moved the decimal place twice. And that kind of worked out because it went from 120 to 12. That is, I just basically lost one place value. If you had made that 11, you couldn't have pulled that little trick. You would have to make this calculation.
Mhm.
But now at the end of the day, to figure out your savings, to answer the question, it's just do the subtraction, which would be 10.51. And that gives me considerable savings going to the LED. I know the college, about starting, 12 years ago, 13 years ago, took a number of years replacing all of our lights with LED. And so there, you have this initial investment in because you got to redo the lighting fixtures themselves. But there's such a considerable savings once you get to that system that within a couple of years you've already got a return on your investment. So,
Mhm.
All right, are we good with that one now?
Yes, sir, I am. Thank you very much again for your help.
Oh yeah, you're no worries. So anybody else? Any other questions? All right. If not, again, reminder that no class on Monday. As soon as we close out class today, I will process this video and get it uploaded and get the link sent out for both 120 class today and now the 120E class. And a reminder that we won't have class again until the 7th. So if no other questions, I hope you guys have a happy and safe 4th of July. I'll be in the mountains down in Pocahontas County, knocking out some. I've skied there a bunch, but I've never ran all the trail out there, so I'm looking forward to it very much. So that's where I'll be, and but I'll be back on Monday, and then I'll certainly. So if you do have questions or whatnot prior to class on Wednesday, shoot me an email, and I can help you out there for sure on Monday. And if something comes up incidentally where I'm staying, I'm not backpacking it in and rough camping. I actually have a cabin reserved, so and which has Wi-Fi. So now, otherwise, my phone absolutely does not work in Pocahontas County. I have to be on Wi-Fi, and it's just the nature of Pocahontas County. It's where Greenbank is, and now that it's kind of going out of operation. They are starting to get some cell towers there, but anyhow, but when I get back to the cabin, I will have Wi-Fi at night, and I will check my email. And if something comes up, I will get back with you when I do get your email. So thank you, and everyone be safe, and thank you, Dave, and we'll be safe out there. And
I do have a quick question. I know that there's a test assigned for 120.
yes.
Again, is it due by tonight, or is it okay to work past that?
Yeah. So, the dates are for pacing. you get 2 shots at, everything else you can do unlimited number of times, quizzes and homework, but the tests you get 2 shots at. So, pacing wise, my hope was you were able to a point you could take that test one time by tonight. But if you're not quite there, you can make your one time tomorrow. There's no penalty.
Okay. All right. Thank you.
Yes, sir. All right, everybody. We'll see you next Wednesday. And again, if you have any issues or whatever, shoot me an email.
Thank you.
Thank you.
Thank you.